Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to talk about the changes to the Save as Mesh dialog in Fusion. So after the September update, I've noticed that there is a change to the Save as dialog. A user left a comment saying that they had trouble with the 3MF export. Their problem seems to be sort of restricted to the Mac OS, and at least as of today, the 3MF export is working okay for me from Save as Mesh as well as the file export menu. But I still wanted to talk about what changed and kind of why I think it changed, and we'll get into some specifics. So in this video, we'll talk about Save as Mesh, sending it to a 3D print utility, and we're also going to dive into using Fusion as your slicer. And I'm going to talk about why I don't do that, but obviously everybody has their own personal preferences, so we'll just give you the information and you can decide for yourself. So to get started, when you select a body and right click and do Save as Mesh, or an entire design and do Save as Mesh, in the past, this dialog would let you do one of two things. It would let you export the design as a mesh, a 3MF, an STL, or an OBJ, or you could click a button that said Send to 3D Print Utility. What they've changed is now we've got a third option called manufacturing, which lets us use the Fusion Manufacturer workspace as the 3D print slicer. Now, I've covered this in content before. I know we did this in a video inside of our 3D print course on learneverythingaboutdesign.com. Probably have talked about it on this channel, but this is basically a slight change. And with it, it impacts at least my workflow, and I'm guessing it impacts some other people's workflows as well. So if we're going to use the Save as Mesh option, it's going to always default to the export type. In the past, it remembered our settings if we use Send to 3D Print Utility, and we could just click the button and go. It's not the case anymore. Now we have to manually go to Print Utility. It will remember the last 3D Print Utility. If you have a couple installed, you may find them in this list. I've got Orca Slicer and Prusa, Cura, and Creality, a couple versions of Creality, and only a couple of them show up here. So I have to use custom, and I have to navigate to the location of the executable file. So from here, when we click OK, what this does is it's going to send the model to the 3D print utility. This is the one that I prefer, the older version 4 of the Creality print. I've done a video on that in the past, talking about why I prefer it. But then from here, we would just slice and we would get a version of our 3D model that we could send to our printer. So that's my process, and that's how I use it. And unfortunately, with this change, it means that I'm just going to have to manually select print utility each time before I click OK. So a little bit of extra work. The utilities menu has an option called 3D print, and this has been around for years. And the main difference is that this one defaulted to having the Send to 3D Print utility checked. That's different now. By default, this one wants to send it to the manufacturer workspace. Now, if you've never used the manufacturer workspace in Fusion, we're going to go through that in just a few minutes. But basically what this does, it's going to create a new setup for us. So you can still select export, you can still select print utility here, but this one is going to default to manufacturing. So currently there is no button that defaults to exporting directly to a 3D print utility. So in order to do that, we'd have to create our own macro, and we would have to have a button that does that for us. So that's unfortunate, because in the past it was really nice to just right click and save as mesh. There is still our file export options, and we do have 3MF, FBX, STL, and OBJ in here. Keep in mind that in a previous update, Fusion did fix the STL export issue. There were a lot of people complaining when using file export because it would use cloud translation. 3MF still does require cloud translation, as does FBX, I do believe. And these two formats send more information along than STL and OBJ do. But when we're exporting from a design, you're really not getting very much else out of the 3MF, at least in terms of what it was intended for. 3MF is meant to carry along 3D printer settings, material settings, things like that. But if we don't have any of that saved in our design, then you're likely not carrying much more information than, say, an OBJ. We're not going to get deep into all these different file types, but just note that you can still export from the file menu, and you can pick FBX, which is not an option on the Save as Mesh dialog, but we do still have OBJ and STL if you scroll down a bit further, and of course the 3MF here. So we're going to cancel, and we're going to go into the manufacturer workspace. And when we're in manufacture, we want to make sure that we go over to the additive tab. And the main thing that Save as Mesh does, or if you click the 3D print utility button, the main thing it does is it starts by creating a new setup for you. Now, the way that the manufacturing workspace works, if you've never used it before, is we determine the type of operation or essentially machine that we're using, whether it's a CNC mill, whether it's a 2-axis cutter like a router, or if it's a CNC lathe. Those will all be in this operation type dropdown. Depending on which tab you're on when you click New Setup, so if I create a new setup from the Milling tab, it will default to milling, but I can select additive from here and go to the additive tools. So the main difference between that new setup button is it's just going to pick the operation type based on which tool tab you're on. The first thing that we need to do for 3D printing is we need to select a machine. Now, here is where this falls apart for me a little bit, because when I was running an Ender 7, the Creality Ender 7 wasn't in here by default, and I had to go to the machine library on Autodesk's website, and I was able to use it. Now I'm using a K1 Max, and it's not in this list either, and it's not on the machine library either. So if I go to the machine library and I look for Creality for additive, there is not a K1 Max in this list, at least not yet. K1 Max has been out for a while now, so I would hope that it shows up soon, but it's not here. So I can't use the 3D print slicer unless I find another printer that has the firmware that is needed to make that happen. But many of you out there have different machines. You may have an Ender 3 or an Ender 5 or something else. So if you're going to be using this, find a printer that you have. In this case, I'm just going to pick an Ender 6. I don't have one, but it should be in your list if you want to follow along, and we'll select it. We'll notice that it puts a sort of a preview of the machine. You get the build volume area, and the model is kind of out here in space. It'll take care of that automatically for us in just a minute. The next thing that we need to do is we need to pick print settings. So this is where things are kind of different from other slicers. There is not really a default when we select a machine. So we select a Creality Ender, or if you select another 3D printer, you don't get a default sort of preloaded material for you. In the local library is only going to have so much, so you do have to think about what materials you're using and what's available. So if we pick FFF, which is FDM, we have to call it fused filament fabrication now, then we select PLA material, and then we'd have to pick our drive type. So for example, these Ender machines, a lot of them by default will have a Bowden tube, which is basically the extruders on the outside, and it's pushing the filament through a tube before it gets to the hot end. Or if it's been upgraded and uses a direct drive, then you could select the direct drive option. Mainly the issue here is that your retraction settings and some of the retraction amounts and speeds, things like that, come into play. And if they're not tuned right, then you start to get issues with stringing as the print head moves around. But we're going to select the Bowden tube one. And from here, we've got this manufacturing models option. So if you've done any simulation or generative design or any manufacturing for that matter, then Fusion in each of these workspaces generates a version of the model. Now, any changes that we make to the manufacturing model, for example, if I add some more geometry that needs to be printed or I make my own supports for some reason, then that only affects the manufacturing model. It doesn't go back to the design workspace. I'm not doing anything with that here, but that's what that is. Post-process for me is more important if I'm programming a CNC machine where we really need to have the program number sorted out, the comment information in a setup sheet. That is not really the case for 3D printing, because most of the time what you're doing is you're either sending it directly to a printer or you're taking a USB and you're plugging it in. There's not a whole lot of setup that has to happen. You're not, building out a tool crib, and you're not making sure that all the tool offsets are right. So in this case, I don't even mess with the post-process tab for 3D printing. I just say, okay. Now it's going to warn me that I didn't select anything. So we can pick an individual body or component if we want. I'm going to say yes to ignore the warning, and that'll pick everything in the design. The next step, it's going to automatically go into what's called additive arrange. So in our design workspace, we've got a user preference option to turn on 2D arrange, and that's all this is. It's just going to arrange the objects inside of the build area. There is some 3D arrange options. So if you're using an SLA machine or a powder bed machine, then you can build objects up in 3D. I covered that probably a couple years ago when that first was released. But in our case, it doesn't matter because we're printing one of these things. We can pad some information here, like how wide we want the frame around, how much space we need between the top. A lot of this really comes more into play when we start to do 3D arrange or we have multiple components that are separate. In this case, I'm just going to say OK, default settings, and it'll slap it right in the middle for us. So now that it's arranged, we need to talk about those print settings. So we picked a PLA, and there's this little object here, a little gear icon that says normal. One of the things that Fusion does that's kind of nice, and other print slicers do it as well, is they allow you to do per body presets. What that means is we can have one version of this whale shark that has 10% infill and one that has 90% infill. We can test those two out. We can print them at the same time. But the big problem here that I have is that you really need to go in and spend a lot of time making sure that your print settings are right. And it's not really a Fusion only problem. Even with default slicers, you will have to make some tweaks to material settings, but it's more so the case in Fusion. And the reason for that is because, again, these values are generic PLA values. They're not configured to the specific machine that you're using. So if you have a machine like a K1 Max or Bamboo Labs or something that currently aren't supported here, then you really have a lot of options for the travel and all these extra sort of advanced options that the firmware supports that you may or may not be able to even deal with here. But we're just going to walk through some of the basic settings. So general, these are going to apply to any body preset. So you're not going to be able to individually configure things like the bed temperature or layer height. But you can already see that I run 60C on the bed temp. The layer height of 0.15, generally I would run probably 0.2. And let me go back in there. Let's go ahead and go back to general. And then I'd probably run maybe 0.28 on the first layer. Travel speed, depending on your machine, I mean, this can be up to 600 millimeters a second. These are all generic settings. Remember, you can't hit enter in these dialogues because they'll end them, unfortunately. And then some generic values. So generate G2, G3 movements. This was one of the original reasons why I started to use the Fusion slicer, because we were able to bring a model in that wasn't a mesh file. And if your firmware supported it, you could get true arc movements from the 3D printer rather than doing a bunch of tessellated lines. That is not unique to Fusion anymore. A lot of the slicers will let you bring in step files and they will be able to generate G2, G3 movements. Unfortunately, when I was doing this with my Ender 7, the firmware didn't support G2, G3, but this is a nice option, especially the fact that you don't need to create a mesh file or an STL file. You can just have your model in Fusion. So now when we look at the body presets, we need to make sure that we configure things like extruder temp, so 200 is probably too low. We also need to look at things like shell. So for example, the normal preset, the number of perimeter walls is 2, but if we go to the strong preset, it's set at 5. If we go to infill density is 25%, the strong is 50. As we go to print bed adhesion, these are probably going to be the same, but I generally turn that off. And as we go to things like support materials, there are some defaults for the supports in here. We have to manually generate these supports, but it'll go to these settings. So the strong supports versus the normal supports will be different. And again, we have things like speed. So this is where we really need to convert the settings from a default slicer for your printer into information that works for you. So what I found is I was able to get decent prints out of the Fusion slicer. I just didn't have the luxury of having those preloaded values from the manufacturer that I could tweak up or down based on how the print was going. You really are starting more from scratch. And you can use values from a material manufacturer. So, for example, if you're using Polyterra PLA, then you can start with their settings. But again, it's a little bit of a science experiment. It takes some time to get right. So once we say okay, we now have the material updated. If we want to add supports, we can come in and do the solid volume support, the bar support, or this setter support option, which allows us to put our part above the build plane. Not something that I would do in a case like this because we made the bottom of the model flat on purpose. But when you go in here, you also have additional options. For example, we do have general settings for the different types of connections. Fusion does support tree supports. There are also some options for things to avoid if you don't want to put supports in a certain area. So you can have a lot of control over these, but just keep in mind that this is a bit more of a manual process. So in a lot of cases with a slicer, what you end up doing is you end up turning supports on or off and then allowing it to build those. But with Fusion, if you don't use those default settings, you need to spend a little bit of time figuring it out. Once you have everything set, you'll need to go to your additive toolpath and then you'll generate it. So once we generate it, this is essentially like hitting slice in another 3D print slicer. And once those have been generated, then we can go through the process of animating it, playing it back, and making sure it's okay. So again, from actions, we'll do simulate. And this will be just like any other slicer. We can pull down through, we can take a look at our supports. We can make sure that we don't have any overlap with any of these print and place features. And everything looks pretty good. If we did accidentally have things like brim turned on, or if we had supports building in the inside areas, this is where we want to make sure that we identify those problems. From here, if we select post process, this is where it allows us to generate the actual code. And you would want to make sure that you are using a correct post. So different machines will require different configurations from this data. This is not really something that you do in a default slicer. So like from Creality, for example, when you select the machine at the start, you generally don't have to worry about the post processor because it's all baked in. With Fusion, however, it will come through automatically based on the machine definition, but you can override that. So you do have to be careful just to make sure that it is correct. Again, program name number, I don't really care about that, but the file name would be important. So you would want to put something like whale shark. And then when you generate it, we're not worrying about NC program. Again, we're not doing setup sheets or documenting anything like this. We could post it to Fusion Team, so you could save all your G code to a project location. We would want to save it externally as well, so we can get it to the machine. And then we can also open it in an NC editor. So there are some other things that we can do in here. There are basic options. These are going to be based on which machine and post you have selected. So for example, certain enders are not going to have automatic bed leveling, so it'll come up as no leveling. If you happen to have added an automatic bed level option to your machine, then you may need to just verify whether or not it's using a G or an M code to enable that. And again, just take a look at these settings. I'm not going to post this, but generally what's going to happen is it would create the G code, same way as any other slicer, and then you would just take it to your machine. So I don't personally use the Fusion slicer anymore. I'm not saying that I won't at some point, but I used it on my Ender 7 a bit. I had better results out of the Creality print slicer, the old one, not the current one I'm using. And with the K1 Max, it's not currently listed in the machine library, so I couldn't use it even if I wanted to. But I do find that taking the time to configure the materials is a bit more work in Fusion, and if that gets kind of cleaned up a bit, and I would reconsider using it a bit more. But there are a lot of nice options in here. So things like 3D arrange and filling the area, the per body presets are nice, especially if you're building a couple of different parts on the same build, then you may want to configure them differently. Of course, things like the bed temperature are going to be the same, but you do have control over even things like nozzle temperature. If you have a machine that's using like an AWS system where you've got multiple spools of material, then you can configure different extruders for different body presets. So there is a lot that can happen in here, but it does take a bit of time for you to set up those presets so that they are working well for your machine. So the main purpose of this video was to talk about Save as Mesh, and hopefully this answered those questions. If you are considering using Fusion as your slicer, then hopefully this gave you enough information to get started. But if you have any questions, please leave a comment and let me know. As always, thanks for watching, and we'll see you in the next one.